Hello everybody, this is the notes for Algebra 2 Trig, week 6, like it says right there at the top of the screen. We are talking about right triangle trigonometry. This is the stuff that we are starting to get into as the whole world started changing. So, right triangle trigonometry, just a quick explanation of how it works and why it works. The explanation goes back to geometry, talking about similarity. And so these two triangles that you're looking at here on the screen, these two triangles are similar because of angle-angle similarity. The right angles is one pair of angles congruent. The 34-degree angles are congruent. That's angle-angle similarity. And so when you have two shapes that are similar, corresponding sides are proportional. And so that's what we're dealing with. These sides are proportional. Okay, it doesn't matter what the actual side lengths are, they're always proportional to each other. And that's what gives us our trig ratios. Okay, all these trig ratios are, when we talk about the sine ratio, cosine ratio, tangent ratio, they are just a ratio of two sides. And so it doesn't matter what the actual lengths are, the ratios are always the same because these triangles are proportional to each other. So that's the real quick explanation of how the trig ratios work. They all kind of like, that's the math behind it, but how we actually use them, we always take the trig function of an angle measurement. So sine of angle A, cosine of angle A, tangent of angle A, whatever the angle is, equals a ratio of sides. And so for sine, cosine, and tangent, we have that that way to say it, the SOHCAHTOA. That's the way to remember it. Sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is the opposite over adjacent. Okay. So in your notes that are available in your Google Classroom, this is the second example in the notes. You are given the sine of angle B right here is 5/8, and the question is, what are the other trig ratios? So the sine function is the opposite over hypotenuse of angle B. Here's angle B. The opposite side is over here. The hypotenuse is always across from the right angle. So sine of angle B is 5/8. Angle B, opposite, 5 over hypotenuse, 8. All right, to find the other trig ratios, we need to know this side. It's a right triangle, so we're going to do Pythagorean theorem. I'm going to call this side x leg squared plus other leg squared equals hypotenuse squared. You go through, solve for x, you get the square root of 39. There's that side. Okay, the other trig ratio. So we got sine, cosine of angle B. Cosine is adjacent. Here's angle B, the adjacent. Root 39 over hypotenuse. Tangent of angle B, opposite, 5 over adjacent, root 39. Okay, there's the three main trig functions, sine, cosine, and tangent. The other ones are just the reciprocals. So, cosecant of angle B. Cosecant sounds like it should be related to cosine, but it's not. That's the way I remember it. So it's the reciprocal of sine. Flip that at 5/8 over, so 8/5. Secant of angle B is the reciprocal of cosine, so 8 over root 39. Sometimes you're supposed to rationalize this denominator. Don't worry about it. We don't need to. And the cotangent of angle B. Flip the tangent over, root 39 over 5. Okay, there's that example. In your notes, there's a couple of problems dealing with the 30, 60, 90 triangles, the 45, 45, 90 triangles. Those are just some very common ratios. We're going to get into that more the last week of school with the talking about the unit circle kind of stuff. So that first example after that section of the notes. Use trig to solve for x. All right, so we got a right triangle. That's what all these trig functions work for, is for right triangles only, these trig ratios. All right, so we're looking for angle x. I couldn't get the degree symbol to work in here, but that is a 24-degree angle. Okay, so we always use one of our acute angles. We got our 24-degree angle. This side 11 is the opposite side. The x is the hypotenuse. So what relates this angle to these two sides is the sine, because it's opposite and hypotenuse. So we always take the trig function of one of those acute angles. So sine of 24 equals the opposite, 11 over hypotenuse. All right, so we are going to try to solve for x. So basically I'm just going to multiply both sides by x. And that equals, or x times sine of 24 equals 11. To solve for x, we are going to divide by the sine of 24. Okay, I don't have my graphing calculator available. If you don't have a trig or a calculator that does trig, you're going to have some options. You can find an app on your phone. I have an iPhone. If you just turn the phone sideways when you're in calculator mode, you'll get your trig functions to show up. If you don't have that ability on your phone, you can go to the web and just look for a trig calculator or trig table. You got all kinds of ways to figure this out. So this is a good enough answer for now. Without a calculator, we can get a decimal version here with a calculator. I don't have mine. All right, the last example. What's the measure of angle B? So the trig functions relate an angle measurement to a ratio of sides. So we're going to set this up the same way. Here is angle B. 8, the two sides that we know, is the adjacent side and the hypotenuse. So that means those three things are related with cosine of the angle to equal adjacent 8 over hypotenuse 16. Now, to solve for angle B, we got to get angle B out of the trig function. And so what we do, I'm going to show you the full detail. What we're going to do is take the inverse trig function. So cosine, that little -1 is the inverse symbol of this, equals the inverse cosine of this. Basically just took the inverse cosine of each side of our equation. These are inverse functions. They cancel each other out. So what we're left with is just angle B. Inverse cosine of 8/16. I will tell you that this is going to be 60 degrees. Now, how I got this, because I know math, but really because it's a 30, 60, 90 triangle with this ratio. This is the leg, the hypotenuse is twice that, so it's a 30, 60, 90 triangle. But again, to figure this out with a calculator without knowing that it's one of those special right triangles, find your calculator. You're going to do inverse cosine of that ratio, and it'll spit out 60 degrees. With all of your calculator work, no matter what problems you got to do, just make sure it's in degree mode. All right, that is a quick rundown of right triangle trigonometry. I hope that's helpful for you. If you have any questions, make sure you email your teacher. They're great people. Bye. Hope you're all doing well.